Hi, good morning. Next theorem, comparison test. So, question करने के लिए पास like question very important theorem. So, prove that integration of a to b 1 divided by x minus a raised to n into dx is convergent. This integral is convergent. ಯಾವಾಗಂದ್ರೆ and if and only if n is less than 1, where a is the only point of infinite discontinuous. Means the given data is improper integral of second kind. For example, integration of 2 to 3 1 divided by x minus 2 raised to 4 into dx. 4 is less than 1, or condition is if and only if n is less than 1, it should be less than 1, means minus 4 equal minus 5 equal minus 4 equal, right? So now check whether it is convergent or divergent. So test markoto depends upon n. Condition is a. This is a. A is the only point of infinite discontinuous. When we say that point is infinite discontinuous, if we substitute a value in this equation function, in this function that gives unbounded. Function is unbounded means a is the only point of infinite discontinuous. This is the concept. Improper integral of second chemical level. So that based on example say that. 2 is the point of infinite discontinuous. E2 is the 1 minus of 0 bರ್ತದೆ 1 divided by 0 bರ್ತದೆ. It means infinity. Function is unbounded. If it is unbounded, that point is infinite discontinuous. Clear? So proof for ಸ್ವಲ್ಪ difficult ಐತಿ. ನೀವು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡ್ತಾ ಬರ್ತೈತೆ theorem. Proof. So given input ಅನ್ನು ಬರ್ಕೋರಿ. Here integration of a to b 1 divided by x minus a raised to n dx is important. So case 1, it all depends upon n terms. So case 1, if n is less than or equal to 0, n is less than 0 or equal to 0, that given integral is therefore integration of a to b 1 divided by x minus of a raised to n into dx is a proper integral. Proper integral. Right? Case 2. If n is greater than 0, the given integral is therefore a to b 1 divided by x minus of a raised to n into dx is a improper integral. Improper integral. For example, this it is 4 ಅಂತ ತಗೊಂಡ್ರೆ ಅಂತಂದ್ರೆ so 2 to 3 1 divided by x minus 2 raised to 4, the given integral is improper integral, right? So ಹೇಗೆ improper integral ಅಂತ ಕರಿತೀವಿ? So limits ಏನದು finite ಅದು, but function ಏನಿದೆ unbounded ಇದೆ. ಯಾಕೆ unbounded ಇದೆ ಅಂತಂದ್ರೆ 2 value x over ಹಾಕ್ಬರಿ, so infinity ಬರ್ತದೆ, means function is unbounded, means this integral is improper integral of second kind. In the same sense, we conclude that so this integral is improper integral when n is greater than 0. Yes, of course, 4 is greater than 0, n value 4 is greater than 0. Using that base, I can write it as this. Clear? Okay. Case 3. If n is equal to 1, less than or equal to 0 ಆಯಿತು, n is greater than 0 ಆಯಿತು, condition is n is not equal to 1 ಇದ್ದಾಗ n is not equal to 1, equal to 1 ಇದೆ ಆಮೇಲೆ ಬಿಡಿಸ್ಕೊಂಡು. So given is a to b 1 divided by x minus of a raised to n into dx. Here a is only point of infinite discontinuous. It means that I can write a to b 1 divided by x minus a raised to n dx. Lower limit ಏನೈತಿ infinite discontinuous ಐತಿ, so it is improper integral of second kind. Epsilon tends to 0. Integration of a plus epsilon to b 1 divided by x minus of a raised to n into dx using this condition. Lower limit infinite discontinuous idre a plus epsilon, upper limit infinite discontinuous idre b minus of epsilon. This is the concept, right? Further examples. Next, so integrate limit of epsilon tends to 0. ಅದನ್ನು ಹೇಳ್ತಿದ್ದಾರೆ integration of a plus epsilon to b x minus of a raised to minus n into dx. So that equal to limit of epsilon tends to 0. So integration of x raised to n plus 1 divided by n plus 1 raised to a plus epsilon to b. Call this equation a. So case 4, what are our cases? Case 4, when not equal to 1 ಆಯಿತು, ಇವಾಗ n equal to 1 ಆದಾಗ ಏನು ಮಾಡಬೇಕು? Take given equation a. Take equation a. So take given equation. Take given integration of a to b 1 divided by x minus of a raised to n into dx. So that equal to integration of a to b limit of epsilon tends to 0. Epsilon tends to 0. Integration of a plus epsilon to b when n is equal to 1 another. 1 divided by x minus of a into dx. Now integration of 1 divided by x minus a means it is log. So I can write it so that equal to limit of epsilon tends to 0. It is a log of x minus of a raised to a plus epsilon to b, right? So that equal to limit of epsilon tends to 0 integration of log of b minus of a minus log of a plus epsilon to minus of a. So get cancelled. So I can write limit of epsilon tends to 0. As epsilon tends to 0, it is log of b minus of a minus of epsilon in the 0 plus a minus a get cancelled. Log of 0. Log of 0 is infinity. Log of b minus of a minus of infinity. So it is minus infinity. It means that it is a divergent. Therefore it is a divergent. Right? So when n is equal to 1 another. Next, n is greater than 1 is the angle square. Case 5. If n is greater than 1 is there, this implies n minus 1 is greater than 0. So take equation a. Equation a. So integration of a to b 1 divided by x minus of a raised to n into dx. That equal to limit of epsilon tends to 0 integration of a plus epsilon to b 1 divided by x minus of a raised to n into dx, right? So take equation a. So integration ಮಾಡಿದ್ವಿ x minus of a raised to minus n plus 1 divided by minus of n plus 1 a plus epsilon to b. You should focus on, concentrate on n minus 1. ಇಲ್ಲಿ ಏನು ಇಂಟಿಗ್ರೇಷನ್ ಮಾಡಿರ್ತಿಲ್ಲ ಅಲ್ಲಿ ಏನು ಬರಬೇಕಂದ್ರೆ n minus 1 ಬರುವಾಗ ಇಂಟರ್ವಲ್ನ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡ್ಕೋಬೇಕು. ಹೆಂಗೆ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡ್ಕೊತೀವಿ ನೋಡಿ. ಲಿಮಿಟ್ ಆಫ್ epsilon tends to 0 x minus of a raised to minus is taking common n minus 1 divided by minus is taking common n minus 1. Why n minus 1 ಬಂತು? It is always greater than 0. If you put n is equal to 1, if you put n is equal to 2, 3, 4 like this, it should be greater than 0. So a plus epsilon to b. Now simplify this, right? So minus keep as it is, n minus 1 is a number, take it outside. So that equal to limit of 1 divided by n minus 1, limit of epsilon tends to 0, right? So I can write the current to minus 1 minus 1 divided by x minus of a raised to n minus 1, a plus epsilon to b, right? So then apply upper limit minus of lower limit n minus 1, limit of epsilon tends to 0, minus 1 divided by b minus of a raised to n minus 1, minus of minus plus 1 divided by b is epsilon. So plus a minus a get cancelled, only epsilon is there. So that equal to 1 divided by n minus 1. So as epsilon tends to 0, minus 1 divided by b minus of a raised to n minus 1 plus 1 divided by 0. So 1 divided by 0 is infinity. This infinity and this is a finite number. So finite plus infinity is infinity. So when n is greater than 1 idaga, so that given integral is divergent. Therefore, it is divergent. Direct rule. For example, it is this. 4 is greater than 1. So this integral is divergent. New previous example ಪರಿಸ್ಥಿತಿಲ್ಲ ಲಿಮಿಟ್ ತಗೊಂಡು ಕತ್ತಿ ಪರಿಸ್ಥಿತಿ. But ಇಲ್ಲ. By using this theorem, so when n is equal to 4 is greater than 1, this integral is divergent. Direct achಕೊಂಡು. So next, last case 6. If n is less than 1, so it means that then n actually to 0 1 minus of n, or I can write 1 minus of n is greater than 0. So take equation A, so I can rewrite like this. Shows that 1 minus n ತರಿಸ್ಬೇಕು ನಾವು ಅಂದ್ರೆ 1 h ಕಡೆ ಬಂದ್ರೆ minus h ಕಡೆ ಹಾಕ್ಬೇಕು. Rewrite this, limit of epsilon tends to 0, x minus of a raised to 1 minus of n. ಇದನ್ನ ರಿವರ್ಸ್ ಮಾಡ್ಕೊತೀವಿ. So 1 minus of n, a plus epsilon to b. Substitute upper limit minus lower limit. So limit of epsilon tends to 0. So 1 minus 1 divided that equal to 1 divided by 1 minus n is taking common. Limit of epsilon tends to 0, right? So b minus of a raised to 1 minus of n. So minus a plus epsilon to minus of a raised to 1 minus of n. Plus a minus a get cancelled. Only choose epsilon. Epsilon tends to 0. What you get? So that equal to 1 divided by 1 minus of n. So that equal to b minus of a raised to 1 minus of n minus it is 0. Plus a minus a get cancelled. So epsilon tends to 0. So we get it is 1 divided by 1 minus of n into b minus of a raised to 1 minus of n. This is finite. Because of a and b are any real numbers. So this is finite. If it is finite, therefore it is convergent. Right? Hence the complete theorem. Practice ಮಾಡಿ ಬರ್ತೈತೆ.